There are about 285 million people worldwide that have some level of visual impairment. They face several challenges navigating in unfamiliar public locations. About 25% of the visually impaired people travel through public locations without assistance other than a walking stick. While this can help navigate to a destination, but this can also lead to a longer routes and wasted time. Our project focuses on designing a device for visually impaired people that is comfortable to use and can help with traveling independently. Our solution is a checkpoint system for the visually impaired that seamlessly integrates into a blind person's walking sticks and can be installed into public building infrastructure without any major upkeep. The navigational aid that we are using here is a radio frequency identification, that is RFID antenna embedded into a walking stick. The layout of RFID tags will be stored in a controller board. While walking, the reader will pick up the RFID tags which will provide the location data. Using this information, the controller board then calculates the shortest path to the destination which will be provided by the visually impaired person. The shortest path is dictated to him by voice commands. The controller board has the capability to detect if the person deviates from the specified path and correct it.
Okay, so we have a variety of instruments here to achieve our objective. We can basically divide all of them into 5 parts. The first and the most important being the controller board. We are using it to control everything here. The next is the RFID reader, the RFID antenna, passive tags, the APR sound IC for storing the audio instructions, and the keypad for storing the destination.
The components we have used in our project include first the experimenter board. This is MSP EXP430F5529 experimenter board manufactured by Texas Instruments. It is the main control board for the RFID reader and the APR sound IC. We have used 2 double batteries as power source. It stores the whole layout of the RFID tags. We are burning it using Code Composer 5.5 developed by Texas Instruments. Then we have our RFID reader. This is PCB of the RFID reader. Here we have utilized TRF7961 IC as the reader manufactured by Texas Instruments. It operates at a frequency of 13.56 MHz. It drives the antenna which is used to transmit signal and receive the unique serial code of RFID tag. This unique code is then sent to the experimenter board. Now we have the antenna and the RFID tags. We have designed this antenna to suit the frequency of 13.56 MHz. It has an impedance of about 107 ohms. We have added capacitors and resistors to match the input impedance of 50 ohms. It transmits the RF signal given by the reader to the tag. These are passive RFID tags. So when they receive signal from reader antenna, they get charged and then transmit their unique ID. We also have the APR sound IC. This is APR 9600 sound IC. We are using it to store voice commands and is controlled by the experimenter board. It has flash storage, so the message retained even after we cut off the power supply. Then we have used the keypad. This is the keypad which we'll use to enter the destination room number. On later stages, this could be converted to a braille keypad which can be used by the visually impaired person. We have also used the UA 7805 and 7808 ICs provided by the Texas Instruments. Thank you. We are using RFID tags that will be implanted in the whole building. The controller stores the location of these tags. Visually impaired or blind will be given stick containing RFID reader. A braille keypad will be attached on the stick which he will use to enter the destination room number. When he does that, the reader detects the closest RFID tag to find its own location. The whole network of RFID tags in the building is stored in the form of graphs in the control board. We will be implementing simple breadth first search algorithm to determine the shortest path. Person will be directed to its location using audio message that will be stored in the APR sound IC. Even if the person gets out on the wrong path or displaces from the path, this system is smart enough to direct him back to correct path. This device also can help blind to move towards to exit in any case of emergencies. This project can be implemented in any type of building, irrespective of its complex design or its multiple levels. Other projects being implemented using RFID are unable to guide a person with such an accuracy. Our system not only increases accuracy, but the ease of setting up and net cost is also optimal as compared to other devices.
So now we'll demonstrate a project to reach destination number 5. We have placed RFID tags throughout the way on the chairs. Now Sagar will enter number 5 on his keypad to reach destination 5.